Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Your one stop for learning very important concepts and very useful things in mathematics which can make you smarter and enable you to handle the numbers very effectively. And that's what we need to crack all those competitive exams and come in the top 1% bracket of students who qualify these exams and get into top universities, top jobs. Quantitative aptitude is everywhere, and qualifying those examinations of quantitative aptitude requires smart work. And one of the very important problems which the students face is when they see square roots in the questions. So today in this video I am going to take up some of the smart tricks or some of the smart things rather you can actually apply in those questions so that your answer comes up very accurately and quickly. So what do we have in the video? This is solving some particular problems involving square roots effectively, that means quickly and accurately. So you need to watch the complete video so that you are aware of such things and you can actually apply them practically in the questions. So before I take up all those important questions, let me tell you about the short tricks ebook. That means it is a reservoir of short tricks which we have brought out specially for all those preparing for the quantitative aptitude exams. And look at these number of exams that it targets. I think lakhs and lakhs of students are appearing in these exams and they are struggling with quantitative aptitude. So if you want to study those 24 important chapters which are asked in quantitative aptitude and you want 300 short tricks of solving them quickly and accurately, then this is for you. It will help you calculate 10 times faster, and what more, it comes with a reasoning course combo, and in reasoning we have videos also. So what are you waiting for? This special combo is for all those school students who want to build up a 10 times faster speed of calculation, who want to excel in mathematics, develop a positive attitude in mathematics, preparing for placement exams, studying at college level, have deep love for mathematics. This is going to benefit you a great deal. How do you get a copy? WhatsApp 9896369963, but make sure you are willing to invest a little bit on your education, right friends? So this combo is the special thing we offer. Now let's come to the concept of the trick which I am going to tell you. Square roots, right? So when we have square roots, there are some basic things we need to understand before we get into the questions. Perfect squares or not a perfect square? That is one thing. Remember, any number which ends in 0, 1, it may be 4, it may be 5, it may be 6, it may be 9. All these unit digits ending in 0, 1, 4, 5, 6, 9 may or may not be a perfect square. May or may not be a perfect square. Just like if I talk about the numbers ending in 6, if you see 256, it is 16 square. But if you come like 10 down or like 50 down, 206, it is not a perfect square. So all numbers ending in 6 are not going to be perfect squares. Only some of them are going to be perfect squares. But yes, it may or may not be a perfect square. But any number ending in 2, 3, 7 and 8, they are definitely not a perfect square. Definitely not a perfect square. So this is the first thing you should know when you are actually starting the topic of square roots. Now whenever you have square root of say a prime number, square root of a prime number, we can't simplify this further. Square root of 3 is square root of 3 only. Square root of 11 is square root of 11 only. But when we have square root of a composite number, what will happen here? We can actually perform one or two steps through which we can simplify it. May or may not again. See, suppose you have square root of 12. Now I can write 12 as 2 times 2 times 3. And since 2 forms a pair, it comes out of the square root and 3 remains inside. So square root of 12 is actually 2 root 3. But had it been square root of 14, alright, this is a composite number, but this is further not simplifiable. Why? Because the factors are 2 into 7 and nothing forms a pair here. So square root of 14 also remains a square root of 14 only. So all square root of prime numbers and all numbers, composite numbers, which have two different factors, you can't actually simplify them. Even three different factors. Like I can give you an example of square root of 42. Now square root of 42 is a composite number. The factors are 2 into 3 into 7. Now what are you going to do with this? No common factors, and square root of 42 is going to remain square root of 42 only. Right? Another very important thing in handling square roots. The next important thing is square root of decimals. So when we have a decimal number in the square root like 0.04, now we should know that any square root of decimal will only be, a perfect square here. This number 0.04 will be a perfect square when it has even number of digits on the right of the decimal. So if you see 0.2 into 0.2, it is actually 0.04. So when you have to find the square root of decimals, the wise thing to do is to get rid of the decimal. So if somebody feels discomfort in getting to this answer, square root of 0.04 is 0.2, then what he or she should do is write 0.04 as 4 upon 100. I just got rid of the decimal, and you can actually write the square root of numerator and square root of denominator differently, and then 2 upon 10, that gives me 0.2 as the answer. Now this is a mental process actually, so you need to be really quick in actually tackling the square root of decimals comfortably. So I'll take some problems and I'll show you how these small things, concept of these square roots will help you a great deal in solving the problems. Likewise, you should know that if we are doing operations on square roots like root 2 plus root 2, it is like x plus x. The square root of primes or the square root of numbers which cannot be further simplified, they are like variables. So just like root 2 plus root 3 is not root 5. Why? Because root 2 and root 3 are two different variables. X plus y, you can't add them, right? So very basic things. Operations on square roots is really important. Okay. Now let's see some questions now. Here we have a very simple question first, in which I am going to simplify square root of 32 plus square root of 48, and in the denominator we have square root of 12 plus square root of 8. Now you can see 32, 48, 8 and 12, the four numbers which I have written here, all four are composite numbers and they are not perfect squares. 32, 48, 12 and 8, nothing is a perfect square, but we can actually make factors because they are composite numbers. And let us check which of them are simplifiable. And by saying simplifiable, I mean if you make factors of numbers like 32 is 2 times 2 times 2 times 2 times 2, and then 48 is 2 times 2 times 2 times 2 times 3, right? 16 3s are 48. And then in the denominator square root of 12, 12 is 4 times 3, that is 2 times 2 times 3, and 8 is square root of 2 times 2 times 2. Now let's see how many pairs are there. 1 pair, 2 pair. So this becomes 2 times 2, 4, and the single 2 remains inside the square root. Likewise here 1 pair, 2 pairs, so 4, and the single 3 here remains inside the square root. Here we have 2, so 2 comes out, 3 remains inside, and 2 comes out and 2 remains inside. Now what happens to this is you can have some common factors now. Between this 4 and this 4, we have 4 as a common factor, so you have root 2 plus root 3 in the bracket. And likewise, between these two, you have 2 as the common factor, so root 2 plus root 3 or root 3 plus root 2 remains inside the bracket. So this factor cancels out and 2 cancels 4 2 times, giving you the answer as 2. Now you can see by the look of the question, it doesn't look like that it will get reduced to 2, but it does. Likewise, you have the difficulty level can rise in the questions. Okay, so you can have some expression in the numerator and some in the denominator, and still you will be able to simplify using prime factorization of the number inside the square root. So let's say another question. This is 3 plus square root of 6 in the numerator, and in the denominator we have 4 different terms. So one is 5 root 3, and then minus we have 2 root 12, and then we have minus root 32, and plus root 50. Now what do we do with this? We have to first find which are the composite numbers in the square root, make factors. Okay, right. So what am I going to do? 3 plus, I will not change root 6 because 6 is 2 into 3, nothing is going to form a pair. And in the denominator, 5 root 3 is not going to change, 3 is prime. Here root 12, so I'll write here, see, root 12, 12 is 2 times 3, so 2 comes out, so 2 root 3. Now when I already have a 2 outside and this is 2 root 3, so 2 times 2 root 3 is 4 root 3, right? And then root 32 is square root of 2 times 2 times 2 times 2 times 2 5 times, right? So 4 root 2. So I'll write this as 4 root 2, and finally the root 50 will be root 2 times 5, so 5 forms a pair, so 5 root 2. See how quickly we can actually simplify them by having the basic knowledge of square roots. So what are we going to do now? Let's identify like terms. 3 plus root 6 over 5 root 3 minus 4 root 3. They are like terms, right? They are like 5x minus 4x. So 5x minus 4x is x. So that is root 3. 5 root 2 minus 4 root 2 is like 5x minus 4x, which is again x. So plus root 2. And there you go. You have something, right? Now comes the important step. Can we simplify this further? Doesn't look like, right? But yes, if you can further resolve 3 as root 3 into root 3, because root 3 into root 3 is 3, right? And root 6 as root 3 into root 2, and leave the denominator without any change, then in the next step you are going to see the magic. What's going to happen here is you have a root 3 which is a common factor, and root 3 plus root 2 remains inside the bracket, and in the denominator you already have root 3 plus root 2. So the entire root 3 plus root 2 cancels out the factor, and final answer for the question is just root 3. See how simplification takes place and how you can actually be smarter in handling these square root problems. Otherwise it's going to be a terrible time, when you can't think that you have to convert square root of 12 as 2 root 3, square root of 32 as 4 root 2, and square root of 50 as 5 root 2. So basics are really important. Okay friends, let's see some more questions. Let's complicate the problem a little bit by having some decimals. So this is the question 3 which I am taking up for this video. So 0.729, okay, and in the denominator 0.00841. Right, we need to simplify this now. What do we do here? I told you whenever you have decimals in the square root, it is always easy to do what? Remove the square root, convert it into a fraction form. Okay, that's one of the easiest thing to do, and that avoids so many errors. So let's try and do that. In the numerator, you can see there is a square root of 0.729. So what happens to 0.729? I can write it as square root of 729 upon 1000. Why 1000? Because after decimal we have 3 digits here. And in the denominator, square root of 841 And how many zeros after 1? 1, 2, 3, 4, 5. 5 decimal places. So 5 zeros. Now since both are in the square roots, the denominator can be cancelled by the denominator. So I cancelled out the 1000 and this 100 is going to go in the numerator now. Right? Very important step. So what will happen to the number inside the square root? 7 to 9 will be followed by these two zeros, and in the denominator you will have this number 841 in the denominator. Now you should know that 729 actually is the square of 27 and 841 is the square of 29. Now if you know some basics of squares, then this should work. Now if this is 27, then double zero will produce a single zero in the square root, and likewise 29 in the denominator. Now either you can leave the answer here or you can actually divide it and convert it into a mixed number. So I think this will go 9 times. 9 times is okay. So 29, 9 and 31, 1, 8, 18, 2, 61. So 9 remainder, 9 upon 29. So you can see this happens to be the simplified form of this answer. Not difficult at all, but yes, you should be aware of some basic things of square roots. Let's have one more question, then we can conclude. This is a previous year question, asked in one of the very prominent exams. So he asked us square root of 4225, right, and minus square root of 1225. These are the two square roots which are given in the question, plus 6 is equal to square root of what number? So we have to fill in the question mark here. So whenever I see a number ending in 25, it becomes so easy for me to find the square root, and that's what is the beauty of short tricks. Now whenever you have a 25, the square root is going to end in 5, and then the remaining number 42, I can write 42 as 6 into 7. I have to write it as a product of consecutive numbers. So 6 into 7, and a smaller one has to be written here. See, square root of 4225 is 65. Now, same thing to be applied here. 25 means 5. 12. 12 is to be written as 3 into 4, see, consecutive numbers. And smaller one is 3, so I'll write 3 here. And then plus 6 is equal to square root of, say, x. Okay. Now 65 minus 35 is 30, and 30 plus 6 is 36. That gives us square root of x, or when you square both sides, x will be 36 square, and your answer for the question will be 1296. Because I know what is 36 square, I could write that directly, but if you don't know, you can use some squaring tricks, which I have been posting. So many squaring tricks I have already posted on the channel, and find the square of 36 using that method. So friends, I hope you get an overview of how these problems of square roots have to be solved, and I'm sure with little practice you are going to get through. Okay, so friends, if you like this video, do share it with all your friends, so that they can also get a glimpse of how the square roots work. And if you have not clicked the subscribe button till now, please do it. And along with the subscribe button, you have a bell shaped icon, so press that and click all notifications, so that you keep on getting the notifications on your mobile of this useful uploads for all the school students and all those who are preparing for the placement exams. Friends, thanks for watching this video, and thanks for your time, and I'm sure you are going to comment below whether it benefited you or not. All the best.